In this video, we're going to take what we know about solving applied problems using trig. We're going to kind of take that to the next level and talk about how we would solve applied problems that this time involve not just the use of one triangle, but two. So in the first example, we're given this scenario where the firefighter sees a fire break through a window. It talks about the angle, or a couple different angles of elevation, one to the windowsill, one to the top of the building. We know the firefighter is given to be 72 feet away from the building, and they want to know what is the distance from the roof to the windowsill. So if I go to the picture and take a look at what I'm actually trying to find in the picture, I'm trying to find this red distance, or the distance represented by that red line segment from the window to the roof. If I wanted to, I could call that x. For now, I'm just going to keep in the back of my mind that that's the distance, that's the piece I'm trying to find. Now, in order to use SOHCAHTOA, I need to have right triangles. And if I look at that red segment that I highlighted, it's not a side in any right triangle. But what I do see in the picture here is I do see a couple right triangles. First of all, the blue right triangle. And second of all, the right triangle that I just made green. And I can't help but notice that if I knew the height of this blue triangle, and I knew the height of the green triangle, then I could simply subtract the two and I'd have that red, or the length of that red line segment that I'm trying to find. And so this is going to be my strategy. I'm going to use what I know about SOHCAHTOA together with the blue right triangle and the green right triangle in order to find some missing sides. You'll find that highlighters are going to be very helpful for you with these types of problems so that you can differentiate amongst the different triangles that you're working with. So I'm going to go ahead and I'm going to separate those two triangles now kind of out of the words and out of all the added stuff that's going on in those pictures. So there's my blue triangle. And there's my green triangle. And as far as what I know from the picture, I know this horizontal length in both triangles is 72. I know that the angle of elevation in the blue triangle is 40 degrees, and that the angle of elevation in the green triangle is 32 degrees. What I'm trying to find again is this height, or the vertical distance in the blue triangle, which I'm going to call x, and the height or the vertical distance in the green triangle, which I'm going to find y, or call y. I cannot, very important that I call these by two different variables because they represent two different lengths. So I can't use the same letter or the same variable to represent both. At this point now, in looking at these two different triangles, I notice that I've got side opposite the angle, side adjacent to the angle, and that's a big clue to me that the trig ratio that I want to use to solve this problem is the tangent ratio, which compares the leg opposite the angle to the leg adjacent the angle. And it really doesn't matter which triangle you pick to work with first. I'm going to go ahead and start working with the blue triangle. So tangent of my angle of 40 degrees is equal to the side or the leg opposite the 40 degrees, which is x, over the leg adjacent to the 40 degrees, which is 72. I'm going to go ahead and cross multiply. So in one direction I find x is equal to, and going in the other direction I either have tangent of 40 degrees times 72, or in other words, 72 times the tangent of 40 degrees. Now at this point, you might be tempted to get out your calculator because that's what we did when we solved the most recent types of problems. However, we're not at the final stage of our problem here. We're never going to get out our calculator till we get to that final stage. We're trying to find the distance from the roof to the windowsill, or that red line segment. So until we're at the stage where we're actually finding that piece, I'm not going to get out or do anything that involves the use of my calculator. But at this point, I've done everything I can do in the blue triangle. I'm therefore going to move on to the green triangle. And again, I'm going to set up the tangent ratio just like I did for the blue triangle, except this time my angle is 32 degrees, is equal to the side opposite, which is adjacent, over the leg that's adjacent, which is 72. And again, what I'm going to do is go ahead and cross multiply. So y times 1 is y, and 72 times the tangent of 32 is the product going in the other direction. But again, this value of y does not represent my final answer, and I therefore do not go into the calculator to plug anything in yet. We're trying to find this distance from the roof to the windowsill? Well, we already said that the distance could be best represented by the height of this blue triangle, subtract the height of this green triangle, or in other words, x subtract y. Well, it just so happens that at this point I have a value for x. My value for x is this 72 times the tangent of 40 degrees. Subtract my y value, which is 72 times the tangent of 32 degrees. And now, and only now, that I'm all set to come up with my final answer for this problem, do I go ahead and get my calculator out and start doing the calculations. So all I'm going to do, and you should double check me, maybe put the video on pause for a minute, and go ahead and plug into your calculator 72 times the tangent of 40 degrees, subtract 72 times the tangent of 32 degrees. And then once you get your answer, you want to round accordingly to the nearest tenth. So when I plugged that into my calculator and rounded to the nearest tenth, I ended up with about 15.4 feet. So my answer to this problem, 15.4 feet. So really, there's a lot that you need to know and remember for these types of questions. Certainly your SOHCAHTOA, this whole notion about keeping exact values in your work until you get to the very end and not rounding until you get to that very end. You need to know angles of elevation and angles of depression. So these are certainly some complicated or complex problems involving trig. At this point, I'm going to skip over Jack and Jill in number 2, and I'm actually going to proceed to the very last page and talk a little bit about question number 2 on that page. So this problem has to do with an apartment window that's given to be 24 meters above the ground, and it talks both about the angle of depression and the angle of elevation. They want us to find the height of the nearby building. So in other words, they want us to find this height right here, which I'm going to call h. And I can't help but notice that h is not the side in any right triangle. We can only focus on and work with right triangles. But what I do know is this angle of depression. Remember that angles of depression and elevation are always formed with the horizontal. So my starting point is up at the top of this 24-meter building. The horizontal is that blue segment right there. The angle of depression is going to be from that blue horizontal segment looking down, and that angle is 38 degrees. The angle of elevation, on the other hand, is always from the horizontal looking up. So same starting point, same horizontal piece, but this time we're from that horizontal piece looking up. So that angle, 63 degrees. And you might see now, starting to take shape in this problem, a couple different right triangles that we could now use in order to go and to find h, or the height of that building. So you might say, just like in the last example, or very similar to the last example, the height of the building is made up of the height of the blue triangle plus the height of the green triangle. So whereas in the first example we did some subtraction, this example we're actually going to combine those pieces together to find the total height. Well, it just so happens I know the height of the blue triangle. The height of the blue triangle is given to me to be 24 meters. So this question is looking pretty good so far right off the beginning. The height of the yellow or the green triangle I'm simply going to label or call x. And then just like I did in my first example, I'm going to take and kind of isolate and pull apart the green triangle and the blue triangle so that I can work with this a little bit less cluttered, with a little bit less stuff going on in my picture. So the green triangle has that angle of 63 degrees. I want to find the side opposite, or x. And in my blue triangle, I know that that height is 24 and that this angle is 38 degrees, but I don't know anything else. What I want you to pay attention to and notice in this question is that the green triangle and the blue triangle have a shared part, that piece right up the middle. That's the piece that usually we're going to want to go ahead and find. And again, we know this because it's shared between the two. Anytime you have a side that's shared between the two, you can usually find it very helpful to go through and to find that piece first. So I'm going to label that piece Y in the green triangle. I'm also going to label it Y in the blue triangle. In looking at the green triangle, I could start with that triangle, but notice that the green triangle has two variables. That's going to be kind of a roadblock to me. And so instead, I'm going to start or begin by going ahead with that blue triangle. Like the first example, the ratio that I want to use is tangent ratio because it compares the side opposite to the side adjacent. So the ratio that I'm going to be working with for this question is, again, the tangent ratio. And in the blue triangle, I've got this angle whose measure is 38 degrees. It's going to be equal to the ratio between the leg opposite, which is 24, and the leg adjacent, which is I called Y. And I'm going to go ahead and cross multiply. So Y times the tangent of 38 degrees is equal to 24. And then in order to undo this multiplication by the tangent of 38 degrees, I'm going to go ahead and divide both sides by the tangent of 38 degrees. So Y comes out equal to the fraction with 24 in the numerator and tangent of 38 degrees in the denominator. Y is not what I'm trying to find. It's not the height of the building. So it is not the final stage. I'm going to leave this as an exact value. I'm not going to get my calculator out and yet doing any rounding. But now that I know what my Y value is, now I can go ahead and take a closer look at this green triangle. Again, I'm working with the tangent ratio. Tangent of 63 degrees is equal to the leg opposite, which is X, over the leg that's adjacent, which is Y. And again, I'm going to go ahead and cross multiply. So X is equal to Y times the tangent of 63 degrees. And at this point, I'm starting to feel a little bit more confident about this question because the finish line or the ending point is starting to come a little bit more clear into focus. Remember or recall that in order to find the height of this building, I needed to take 24 and I needed to add X. Well, I've got an X value now. So I'm approaching the point where I'm ready to put the finishing touches on and be done with this problem. So remember, again, that the height of this building was equal to 24 plus whatever X is. And so now I can go and I can do some substitutions. 24 plus Y times the tangent of 63 degrees. But we know a Y value. We know our Y value is this 24 over tangent of 38 degrees. So I'm going to plug that or substitute that into my equation in place of the Y. So 24 plus the fraction 24 over tangent of 38 degrees. And we were multiplying that times the tangent of 63 degrees. So I'm now finally at the point where I'm ready to do some calculating. I'm going to go ahead and pick up my calculator. You should also. And when I put this into my calculator, I'm going to be very careful to put this in exactly how I see it. I'm going to put in the whole number 24. To that, I'm going to add the fraction where 24 is the numerator and tangent of 38 degrees is the denominator. And I want to multiply that fraction times the tangent of 63 degrees. So when I plug all that into my calculator and round to the nearest meter, as required to do in this question, I find that the height of the building is about 84 meters. So these are definitely some really intense, involved, complicated trig questions. Please don't be afraid to ask if you have questions or if there's something that I said during the video that doesn't make sense. The next time you come to class, I really do want you to ask. So you might find it helpful if you have a question to write it down right now so that you don't forget.